Hello and welcome to December bonus number 1. This will be a two-part series that will take place over the remainder of December. Both of these videos will cover the genealogy of different crop species. For our first episode, we'll cover the genealogy and genetic diversity of Iranian grapevine cultivars. To that end, we'll talk about a paper by Dr. Hadidinejad. Within Iran, the germplasm is estimated to be consistent of 500 cultivars, but it's probable that some of them are just synonyms for one another, and several of the cultivars may be genetically identical, and could be categorized as one singular cultivar of slight variation, due to the environment being grown, or perhaps a sport of a pre-existing cultivar. Due to the tendency for self-pollination, and the nature of the unknown levels of how many cultivars are actually there, this researcher hopes to find out the pedigrees of all the different cultivars within Iran to see how closely related they are. This is done through extraction of DNA as well as controlled crosses between existing cultivars. And here are the results. DNA templates from 23 cultivars were amplified by 14 using cutting-edge genetic technology. Using this method, they were able to separate the cultivars of grape within Iran into 4 distinct genetic groups. Within Group 1, there's a cultivar Rahibi and 3 progeny cultivars. This cultivar held 50% similarity to a great deal of the other cultivars within Group 1, with one cultivar showing 60% similarity. Rajabi. Within the second subgroup, Tabrizi was found to be the foundation of a great many cultivars, with the exception of the cultivar Gazelle, which it is only 35% similar to. The third group is first split into several other groups. Subgroup 1 consisted of a 96 and 100% genetic similarity, respectively. The second group consisted of several cultivars that have a similarity value of 86%, with a few exceptions showing that they had 70% similarity. 2 cultivars, Alibaba and Al-Ghiri, were also found in that subgroup, with Alibaba showing a similarity value of 65% to the progeny. Yaguti also showed an average similarity to the progeny of 7. Within the fourth group, the 2 foundation cultivars were Dismeri and Muscat, as well as Ascari. A great deal of the cultivars show 66% relationship with Ascari and Dismeri, with Muscat hanging around the 60% similarity in many of the cultivars on average. Based on this genetic information, it was concluded that, through genetic analysis, that a great deal of the cultivars are very closely related, and that the progeny, like the parents, have similar backgrounds, and were likely derived from a very restricted population. The research also found unique alleles within the grape germplasm, allowing for better identification of cultivars. In terms of genetic diversity, the genetic diversity of the grape germplasm was lower than expected by common experiment. This indicates, as was said before, that the population that much of the native Iranian germplasm is derived from is far more restricted than expected. The genetic differences between red sultana and sultana seems to be berry color, indicating that red sultana might be just a simple sport rather than a different variety altogether. It was also found that 2 common cultivars within Iran, Rajabi and Gazelle, likely share the same parent. When comparing morphology and genetics, it was found that those that had different morphology also had slightly different genetic variations, indicating that crossbreeding of parents with similar genetic background but with different morphology could limit the amount of inbreeding depression. It was also mentioned that this study could also be utilized in determining which parents would be better suited for a backcrossing program. It was also concluded that seedless grapes, when crossbred with seeded grapes, produce better progeny for hybridization because the risk of self-pollination is prevented. As seen on this family tree created through the genetic analysis, Tabrizi, Gazelle, and Tabrizi are likely derived from an initial common ancestor that was then crossbred with other things to give rise to different lineages. This would include Rajabi, Tabrizi, Gazelle, and several numbered cultivars. The rest of the cultivars seem to be derived from a different lineage, but both lineages seem to be derived from a single common ancestor. Given this founder effect, would speculate that the introduction of new germplasm from other parts of the Middle East could be done to improve the genetic diversity of grapes within Iran. But that would be my speculation. And that will covers everything. Thank you for watching. Hello and welcome to the last episode of December Bonus. In this episode, I'll talk about the genealogy of strawberries. Strawberries are derived from hybridizations between Fragaria chilensis and Fragaria virginiana. Between the late 1700s and the early 1800s, the first work on strawberries was written that included the phylogenetic tree of all the cultivars. The focus of the study I'm citing is the analysis of 134 North American cultivars developed between 1960 and 1985, because in the previous study it was found that 20 founder cultivars of the 53 founders they had found contributed up to 85% of the genetic variation within the North American population, indicating that our cultivated strawberries are derived from a very narrow genetic pool. This paper by Dominique D.A. Pincott hopes to verify or refute this claim. To this end, cultivars obtained by following more than 807 documents, databases, and other sources were collected. This material is collected from electronic pedigree databases for public cultivars developed by the public breeder Thomas St. John, the former strawberry breeder at Driscoll, California, scientific technical bulletins, popular press articles, and various garden catalogs, and various accessions, wild forms, pre-existing cultivars, and so on and so forth, were cataloged and obtained. These populations were then divided into the cosmopolitan population and the California population. The California population is cultivars that are bred in California, and the cosmopolitan populations are everything else. Utilizing different algorithms and calculation formulas, the researchers then determined a full genealogy of the cultivated strawberry, as far as they can gather. And here are the results. The first thing that was discovered, based on the 1,235 cultivars currently in circulation, only a small number of them had pedigree listings readily available. Of that number, 1,184 cultivars had no pedigree available. The research done also found that, based on current SNP analysis, the error rates were negligible, ranging between 0.06 and 0.37% error rate. And by using specific thresholds, the parentage of all the existing cultivars could be discovered with very little problem. Based on that genetic analysis, it was found that between 80 to 90% of the individuals of the Californian cosmopolitan pedigree were extinct, and that many of the founding cultivars are now lost, as in, they no longer exist. But most of the genetic diversity found within those ancestral lines seems to have been preserved within their progeny, surprisingly enough. This was based on the analysis called the social network analysis to determine the genetic variation within these populations, comparing against potential expected variation from ancestral population. There are distinctive differences between the progeny in the California population that were not found in the cosmopolitan population. There appears to be very little genetic divergence in the cosmopolitan population, while there's extreme genetic divergences within the California population. It was also found, although the genetic diversity has been progressively reduced by bottlenecks in selection, a great deal of the genetic diversity has persisted within the California population, but it was found to be unevenly distributed across the different cultivars. The work in genealogy did not uncover pedigree records for the cultivars developed between 1714 and 1775, although it has been confirmed that this was the period following the initial migration of Fragaria chilensis ecotypes from Chile to Europe. The only heirloom cultivar we know of that has the full pedigree listed out is Madame Matot, but of course this is not a complete list, as not all the cultivars could be found today. But what is interesting is that one of the primordial cultivars, Madame Matot, is traced back to Chile de Bacasti, one of the original wild foundation clones of Fragaria chilensis, imported from Chile to France by a plant explorer. It's likely that several of these cultivars are likely derived from the accidental crossbreeding that happened in strawberry patches in times gone by in the early 1700s. It wasn't until 1766 when the prospect of interspecific hybridization was discovered, which may explain why the pedigree is so difficult to discover. The nature of the Fragaria virginiana cultivars, or wild accessions, that were utilized to breed the earliest strawberries remain unknown as well, although several pedigree records indicate that some of the cultivars were large early scarlet, old scarlet, and Hudson's Bay, which are all extinct now. There's also 76 anonymous Fragaria chilensis founders within the pedigree records, as well as numerous Fragaria virginia anonymous cultivars. But it's likely from this foundation that the first foundation stock plants that were used to breed our cultivars were derived. But once the hybrid origin of Fragaria ananassa became widely known, domestication began in earnest with extensive crossbreeding between the hybrids and extensive crossbreeding between the two foundation species, with extensive tapping into the wild germplasm to further augment and improve the strawberry. Using genetic analysis, it was found that there are 1,438 founders in the genealogy of the cultivated strawberry, most of which were initial hybrids, specifically 1,171 hybrid strawberry accessions, 65 Fragaria virginiana accessions, 112 Fragaria chilensis accessions, 10 accessions of unknown origin that are octoploid, and small contributions from species of various ploidy that constitute 80 individuals, of which 44 are Fragaria vesca. 95% of the founders have contributed about 99% of the genetic diversity, with what little remained being contributed to by the diploids. In modern times, more genealogy has been made, and specific founder cultivars derived from that initial population have had greater effects on our cultivars within different places than others. Cultivars found in the Albert Eller gene pool included 4 Fragaria chilensis, 5 Fragaria virginiana, and 40 hybrid strawberries. It is these cultivars that made up the genetic foundation of the California breeding lines and cultivars, the hybrid strawberry contributing 85.5% of the genetic material, with the rest of it being contributed by the Fragaria virginianum population of 1.8%, and the remaining 12.7% being contributed by Fragaria chilensis. During this time, the ever-flowering mutation was found in a subspecies of Fragaria virginia called glauca. This strain was called Wasatch. This was then incorporated into all the current cultivars in the 90s to breed the day-neutral variety, with every single day-neutral cultivar having the Wasatch ecotype in the genetic pedigree of the day-neutral cultivars. In the cosmopolitan population, it was found that 26 Fragaria chilensis, 24 virginiana, and 490 regular strawberries were acting as the foundation for the genealogy of the cosmopolitan population, with 79.9% coming from the hybrid population, and the remaining percentages were 4.6 for Fragaria chilensis and 14.1 for Fragaria virginiana. It appears that there's more virginiana parentage within the cosmopolitan varieties than there is in the California varieties. The reason why will be covered in the all-tech exclusive video in the coming weeks. It was also found that, on average, of 15.5 years per generation, given that there's been 200 years of breeding approximately, there's been approximately 12 to 13 cycles of selection over the course of our breeding history when it comes to strawberries. And the breeding cycle's only sped up since then, making pedigree analysis a lot more difficult going forward. And that all concludes everything. Thank you for watching. Hello and welcome to Apple Genealogy. We'll talk about the primary origin of apples, their pedigree, and history. The primary origin of the apple is the Tian Shan Mountains in Central Asia. The primordial form of these apples was Malsiversi. It is from this wild species that all apples were domesticated before being moved to Europe through Silk Road. Persia was a major player in the domestication process. However, the primordial strains of apple in this region are derived from crossbreeding between Malus diversi and Malus orientalis. These strains would pass into Europe and from there intermix with European credible species such as Malus sylvestris and Malus baccata and its relatives. It is from this stock that British, North American, and European species cultivars are derived. A, a paper by Dr. Matthew Ordridge utilized DNA SSR markers and specialized genetic software in order to elucidate the pedigree of different apple varieties. And here are the resulting cultivars and the results of that study. As you can see, they're able to confirm or correct the exact pedigree of a great many cultivars. Key features within apple breeding and key players would be Golden Rennet and Nolan Pippin. Nolan Pippin was found to be the ancestor of Ashby's kernel, a famous apple within Great Britain. This is despite the fact that the Nolan Pippin is documented to be younger than Ashby's kernel, although the genetic evidence seems to show otherwise. This indicates that the Nolan Pippin is actually older than its current name, and likely existed prior to Ashby's kernel under a different name. Golden Rennet was also used extensively in breeding different varieties. Golden Rennet is an old historic cultivar that's been known since the 17th century. It's speculated that Blenheim Orange and Orleans Rennet could both be offspring of Golden Rennet. Others suggest that Orleans Rennet is actually intermediary between Blenheim Orange and Golden Rennet. All of the genetic evidence suggests that both cultivars are in fact siblings. Now onto the final primordial cultivar we'll cover, Cox Orange Pippin. It was initially thought that Cox Orange Pippin was a hybrid between Ripson Pippin and Blenheim Orange. The genetic evidence shows that this is not the case. The actual pedigree of Cox's Orange Pippin is Rosemary Russet, a descendant of Nonpareil and Margil, one of the ancestors of Ripson Pippin. Now onto the foundation cultivars of North American and well, modern breeding in general. Since prior to the 1930s, in the 20th century, at least 1 5 cultivars were ascended from either Cox Orange Pippin, Golden Delicious, Jonathan, Red Delicious, or Macintosh. Indeed, of the many cultivars studied in one research paper, it was found that 64% of the 439 cultivars had at least one of the 5 foundational cultivars within its pedigree. Macintosh being heavily used in Canada, Golden Delicious being used extensively in Japan, China, Australia, and New Zealand, as well as Western Europe, and to a lesser extent, the United States. Jonathan was mostly used in Western Europe and the United States. Cox Orange Pippin was utilized extensively in the United Kingdom and Europe, where Delicious was used extensively in the Pacific Rim countries and United States. And over time, the amount of times that these cultivars have been used has only increased in the breeding process. Why, you may ask? It's been found that the color red creates a sense of urgency and making it suitable for clearance sales. It also encourages appetite, hence why red is frequently used in drive-thrus like McDonald's. It was also found that off colors like aberrant colored patterns decrease appetite. Hence the constant search for bright red monochromatic apples, which is why the gene pool has been shrunken somewhat over time. This can be found within this paper we see right here, done in Nova Scotia. And this is just a quick explanation on how it works. Multicolored fruit are appealing if there's enough colors within the pattern. If it's, however, a single prominent color, off colors reduce marketability. Now on to the Kazakhstan apple germplasm and their pedigree. Most of the pedigree of Kazakhstani apples are derived from 2 different cultivars and have 2 different genetic groups. One genetic group is close related to Golden Delicious, which is incidentally one of the foundation cultivars mentioned before. The other is called Apport. This cultivar makes up the second group in terms of the foundation cultivar pedigree. Apport is a close relative of the Malus specimens found in that region. Now we'll cover the foundation stock of the Minnesota breeding program. Specifically, Honeycrisp. We'll be covering the Minnesota breeding program in greater detail in an alt-tech exclusive video. But for the time being, you'll talk about the pedigree of the main cultivars. Frostbite is derived from a crossbreed of 4 different varieties. The first is a Melinda X Duchess of Oldenburg hybrid, which was then crossbred with another hybrid, which is the Duchess of Oldenburg and Uri's Large Red. These two hybrids were then crossbred to create Frostbite. Frostbite was then crossbred with Northern Spy to create Keepsake and Sweet 16. Keepsake was then bred with MN 1627, which is a crossbreed of Duchess of Oldenburg and Golden Delicious. MN 1627 and Keepsake, when crossbred together, created Honeycrisp, one of the most popular apples in North America right now. The primary goal of this breeding program was to breed hardy apples. Melinda is a very cold hardy apple, hence its constant use, and its heavy amount of pedigree found in various cultivars in Minnesota. The full details of the breeding program, like I said before, will be covered in an Altec exclusive in the future. Next, we'll cover free apples from the PRI program. The PRI program was a genetics program founded by 3 different universities, Purdue, Rutgers, and Indiana, in conjunction with the USDA. A great many of the co-op apples are made by crossbreeding Malus floribunda, which has a single gene for scab resistance, and Rome Beauty. It's from this stock that various cultivars were made by back-crossing this hybrid into other common cultivars. Rome Beauty X Malus floribunda was used extensively to breed different varieties. My apologies, there's some technical difficulties. Let's continue. For Co-op 38, or as we call it, Priscilla. No, not Priscilla, Gold Rush. Was made by crossbreeding the Rome Beauty Malus floribunda hybrids together, two sibling crosses, followed by crossbreeding that with Golden Delicious, followed by crossbreeding that with Melrose, followed by crossbreeding that with experimental cultivar called Illinois No. 2, which is a wine sap open pollinated line, and crossbreeding that with Golden Delicious again. Priscilla was made by crossbreeding Rome Beauty and Malus floribunda, crossbreeding those two seedlings together, then crossbreeding that with Golden Delicious, crossbreeding that with Macintosh, and then crossbreeding that with Starcane. Gold Rush was the 10th apple cultivar developed in the PRI program. Priscilla was the 2nd apple cultivar developed in the PRI program. Priscilla was introduced in 1962, and Gold Rush was introduced in 1973. The last cultivar in our hit list will be Crimson Crisp. And this is the most complex of the pedigrees, but you can basically get a gist of how it was bred from this pedigree map you see right here. Now onto some speculation. First, you have to talk about Margil. If you recall correctly, Margil does not have a specific origin listed in any of the papers. If you look at the origins of Margil, based on the work by Pomifrus, it was found that it was grown from seeds imported from France. Now, there is some possible cultivars just based on morphology that could pertain and act as possible ancestors to this cultivar. Renette French, Renette de Charmes, and Corpan du Plat. Corpan du Plat is a very likely option because although it doesn't look it on its image, it does have a very similar color feature to Margil, Cox Orange Pippin, and Ripson Pippin. And these traits seem to pass on reliably to its offspring. Like, take for instance, these are both direct offspring of Cox Orange Pippin. Kids Orange Red is a crossbreed between Red Delicious and Cox Orange Pippin. And this is another hybrid between Cox Orange Pippin and something else. Although I cannot remember the cultivar name off the top of my head. But as you can see, the color seems to be relatively conserved from offspring and to parent and vice versa. This brings us to the lineage of the pear drop flavor profile. Pear drop flavored apples such as Ashmead's kernel, rosemary russet, and whatnot seem to be derived from nonpareil because rosemary russet, an apple of similar flavor profile, is derived from the nonpareil. So it's plausible that Nolan Pippin is derived from nonpareil. They have similar features in terms of similar russet shape. They also have similar flower color. Ashmead's kernel, Brownlee's russet, rosemary russet, and nonpareil seem to have similar features in terms of flower morphology as well, which also indicates a plausible common ancestor as well, although this is once again speculation. We'll conclude by completing the lineage. If we go back a ways, Renette de Carmes and Renette de Holland are ancestors of Blenheim Orange, but we already know that Blenheim Orange is derived from Golden Renette. So it's plausible that either Renette de Holland was crossbred with something else, plausibly Golden Renette, to create Blenheim Orange because it's genetically confirmed that Golden Renette is one of the ancestors of Blenheim Orange, or that Renette de Holland is the ancestor of golden rennet. These are the two plausible explanations on the relationship between Blenheim orange, rennet de Holland, and golden rennet. Possibility number one is rennet de Holland crossbred with golden rennet to create Blenheim orange, or that somewhere in here is golden rennet. And I'm in no spot to determine how it happened. Here's the sources that I used. Thank you for watching.